just takes practice. And I mean, I don't want to spend too much time on this. I want to just just dip your toes in the water a little bit, and you'll see this later on in more detail. You are going to do a little bit, well, Mrs. Jones and I will figure out if we want to do it this year or next year, but you're going to do a little bit more with this. Like I say, it might be at the end of this year if we have time. It could be next year where you learn slightly more advanced matrix stuff. But for now, it's just a shorthand way of doing algebra with the linear system. Okay, so where were we? We had left off, just quick reminder, this is row echelon form, right? And the idea here is that we just want to get a decreasing diagonal of ones, zeros below and to the left, and everything to the right and above would just be numbers, right? And what that allows us to do is just, kind of work backwards. This is where we're going to bail if we use row echelon form instead of reduced row echelon form. Once we get it to here, we just convert it back into a simple linear system that we can easily solve at this point because we know the value of, for example, in this 3x3 system down here, we know the value of z. We could plug that into the second equation to find the value of y. We could plug both of those into the first equation to find the value of x, okay? So here's where we had left off, right? This is the system we were working on. So this is what we start with. We convert that into an augmented matrix. Here's what it looks like. And here's what we had done, okay? So this first stuff, like we had decided we were going to add up rows 1 and 3, which was good because it gave us a 0 there. We took -3 times row 1 and added it to row 2 so we could eliminate that first coefficient there also. Thank you. And there you go. It's looking better. Okay, here's where we kind of this might be something we want to revisit. So look at our next step here. So we multiplied row 2 by -1/4 to make that a 1. But what's the disadvantage of that? Anybody see? What do you think, Deacon? Yeah, we get a fraction. So we don't necessarily have to make that a 1 right away. Our goal could be to leave these as bigger coefficients, and then in the very last step, all we'd ever have to do, yes. Oh, I just looked. I don't know my glasses on. I saw the brand part, and so Brandon's not here. All right, sorry. So we don't necessarily have to take care of that right away. We don't really want to introduce fractions, right? So we could go through and try to make these all zeros and these all, the rest of this stuff, numbers. And then once we've accomplished that, the very last step would be we could go through and multiply by a fraction and turn those into ones. That way we don't have to battle the fractions all the way through, okay? Which we started doing. So once we got to here, then we were going to turn this into a 0, right? And how are we going to do that? We were going to multiply -3 by row 2 and add it to this one to give us a 0 there, which is fine. We did that, but again, we've got fractions in there. Not the end of the world, but cumbersome. And at that point, we want to make that a 1. So we multiplied this third row by -2/7, and we got it into echelon form. So at this point, we could bail if we wanted to, right? We could turn this in echelon form. What is this telling us? So what does this row say? Z equals 4, yeah. So we know one of them. How about this row? Y, you mean? Y plus 1/2 Z equals 4. Well, I could plug this value in there and solve for Y, right? And then the top one, x plus y plus z equals 9. And now I would have the values of both z and y, which I could plug in and solve for x. Okay, make sense? That's fine. You could stop there when you get it to row echelon form, and that would be okay. Okay, what else could we do? We've got it in this form. If I wanted to put this into reduced row echelon form, what else do I need to do? Multiply. Okay, so there's a couple things. We want to get now, if we want to put it in reduced row echelon form, we want to have ones there, and all these three spots would have to be zeros, right? Okay, so we're just going to do more algebra that way. So we could take, there's a couple things we could do here. So we're trying to turn that into a zero. Which is the row that's going to help us do that? Everybody see that? If I want to make that a zero, am I going to use row 3 or row 1 to do that? Everybody see I want to use row 3 because row 3 is set up perfectly. These are both zero coefficients. So if I multiply row 3 by something, those stay zeros, right? I want to subtract 1/2 from this slot. So what would I multiply row 3 by? I could multiply it by negative 1/2 and add it to row 2, or I could multiply it by 1/2 and subtract it from row 2. Same thing, right? Everybody get that? So here's the step that we're going to take. We're going to do row 2. I chose that way. Row 2 minus 1/2 of row 3. Okay, so what's that going to give us? If I do row 2 minus 1/2 of row 3, the first two slots stay the same. The first two entries, right, or the first two coefficients, right, in the second equation stay the same. But if I multiply this guy by 1/2 and subtract it from this one, that's going to give me a 0, right? If I multiply this guy by 1/2 and subtract, or sorry, this guy by 1/2 and subtract it from row 2, 1/2 times 4 is 2. 4 minus 2 is 2. Okay, give me thumbs on that. Does that make sense? You see the logic there? So we always want to kind of work from the bottom up. Okay, now that we're to here, we need the last two things if we want to put this into reduced row echelon form would be that those two coefficients need to be 0. Okay, easy to do though. How could I turn this one into 0? Okay, and then add it. Or alternately, I could just subtract row 2 from that one. Same thing, right? Okay, so there's our next step. We could just subtract row 2 from row 1, and that's going to make that a 0 and that a 7, right? Everybody get that? Okay. And then last step. Yeah, subtract 3 from 1. Okay, to get rid of that and make that a 0. And there we have it. Okay, and that's our solution, isn't it? That's telling us x equals 3, y equals 2, z equals 4. Okay. Now let's go back and let's just look at how we started to do this yesterday. And I made that one little fix where I had the row operation in the wrong row. But we could do this a little differently also. We could add rows 1 and 3, which is useful to us, right? Because then that makes that a 0. We could multiply negative 3 by row 1 and add it to row 2, just like we did yesterday, okay, and get that. Okay, but now let's not bother trying to turn those into ones yet, okay? At this point, we could do R2. Look at this one. We could do, I could make a 1 pretty easily by combining those two rows, couldn't I? Right? If I did negative R2 minus R3. So if I multiply this one by negative 1 to change all the coefficients and subtract that, that's pretty convenient, isn't it? Everybody see that? So change these signs, subtract that row, and I get that. Okay? Now what? Say it again. How did the... because how do I get a 4 here? Yeah, you're right. But I changed the signs first. So this becomes positive 2 minus negative 2. Does that make sense? Right. So I'm doing two things here. I'm multiplying row 2 by negative 1 to change all the signs. Then I'm subtracting the bottom row. Okay. What do you think might be a good idea next year? How could I, like, you see a convenient way here to get rid of that?
Multiply the top row by 3 and subtract the bottom row 2.
By the top row, you mean this one, right?
Row 1.
Oh, row. Okay, now the problem with row 1 is if I multiply row 1 by something and subtract this, then I'm going to introduce a coefficient there, right? Remember, my goal here is I want to make this thing look like, I want to make it look like this, where I get 0 and then 2 zeros, right? To put that thing into triangular form or row echelon form. So again, is there a way here? Is that where we are? Yeah. Is there a way here that I could conveniently get rid of that? Yeah, multiply row 2 by negative 3 and add them, or multiply by row 2 by 3 and subtract. Either way you do it, right? Doesn't really make any difference. Either way is going to accomplish the same thing. So what did I do? I multiplied row 2 by negative 3 and added them, okay? So if we do that, multiply row 3 or row 2 by negative 3 and add those, that's going to give me negative 3 plus 3 is 0, right? So that's a 0. I'm going to get negative 12 plus 2 is negative 14. And then negative 63 plus 7 is some big number, negative 56. Okay? Good. Now, what could I do to that bottom row? You're right. But I want to make that a 1, right? By negative 14. Good. Okay, same thing as multiplying by, oh, what did I do there? Does 14 not go into 56? Oh, I guess it doesn't. That's right. You were right. Yeah, 14 doesn't go into 56. So I'm just going to divide, oh, what the heck? I think that was supposed to be a 14. That's supposed to be a 14, right? Because 14 times 4 is 56, yeah. So that's, I got to change that. This was supposed to be negative 1/14 R3. Okay, so I got the bottom's taken care of. Now I can just work my way up. There's echelon form, right? And that's a form, this is a better version of echelon form than we had in the last one because there's no fractions, okay? Let's work our way up and put this into reduced row echelon form. Any questions so far? You're kind of getting the hang of this, right? So the goal is you just got to be strategic and find ways to make the second row first coefficient is 0, third row first two coefficients zeros to get it into that triangular form, right? Now, what could I do to make that a 0? Exactly, right? Because now that I've got a 1 there, I can multiply this by anything I want to and subtract or add, right? So we're just going to multiply by negative 4 and add it to row 2. Okay, so that's going to give me negative 4 times 1 is negative 4 plus 4 is 0. So I got my 0. Negative 4 times 4 is negative 16 plus 21 is 5, right? So we're almost there. And then now this is pretty trivial, right? This is kind of where we were last time. I could just subtract second row from first row to turn that into a 0, and subtract the third row from the first row to turn that into a 0. Okay? Make sense? All right. So on the assignment, like you're going to see some different words. Don't get wigged out by the words. It's not a big deal. So some of them are going to say, I took these from a bunch of college texts. It's impossible to find matrix stuff in high school texts. They never have them. So solve the system of equations using matrices. The instructions on on this one would say use the Gaussian elimination method with back substitution. So what does that mean? Just so you'll hear these words again. Gaussian elimination just means row operations. With back substitution means that you're stopping at row echelon form and you're going to solve the system from there. You're not going all the way to put it into reduced row echelon form. That's what Gaussian elimination tells you to do. If you see one that says use Gauss-Jordan elimination, that means when you add Gaussian versus Gauss-Jordan elimination, Gauss-Jordan elimination, you'll learn this in college. That just means you're going all the way to put it in reduced row echelon form. That's all that's telling you to do. And really, it'll be pretty obvious when you get to those questions because it's going to tell you to enter your answer in reduced row echelon form in this kind of a problem. So don't let the words freak you out. It's not a big deal. I know they're big sounding words. We've never talked about them. That's all that that's the only reason that they're there, right? Okay. Let's practice one more of these. How about? So what can we do here? First of all, we got to represent the matrix, right? Give me thumbs on that. Does that make sense that that's the matrix that corresponds? Okay. So what do you think?
You multiply the third row by -2 and subtract it from the second.
Perfect. Yeah. Or -2 and add it, you mean?
Oh, yeah.
Yeah, -2 and add it. Yeah. Good. So we could go, or we could do we could multiply the third row by 2 and subtract the second one. Same thing, right? Okay, so these are going to become, it probably would have been easier to just multiply that by -2 and add them, wouldn't it? I think that would have made more sense than writing it this way. But if we do that, so this is going to become, let's do it that way instead. If we multiply the bottom one by -2 and add them, I'm going to get a 0. I'm going to get, okay, the one advantage is instead of this being a -6, now it becomes a +6 if we do it this way. That's the only advantage, right? If we're multiplying this one by 2 and subtracting. Multiply this one by 2 and subtract. That gives me -2 minus 5 is -7. 18 minus -6 is 24, right? Make sense? Okay, so we're getting there. We introduced a 0. That's good. Okay, now what? I need ultimately to make that a 0 and that a 0. Take your pick, which order. Do you see a way to make that a 0? Okay, good. Multiply the top one by 6 and add them together, right? Good. Okay, 6 times row 1 plus row 2. What's that going to give me if I do that? Okay, that's going to give me, and notice now, this is kind of a slightly newer notation. You can just string you can write these out in a string of different maneuvers by just each time you do row operations, you create a new matrix, right? Just makes it a little more compact. So 6 times row 1 plus row 2, that's going to make that a 0 there. What's that going to be? 6. Good, because I get 6 times 1 plus 0. What's this going to be? -7. Good. 6 times -2 plus 5 is -7. What's that going to be? +24, you mean? Yeah. Yeah, good. Okay. Now what? What am I going to? So that's good. Look where we are now. We've got zeros there and there. I just need one there, but that's easy. What do I do to get a 0 there? Okay, good. Now I don't want to use the top row because if I use the top row, then that 1 is going to cause problems. I'm going to get a number there, right? Exactly. I could just subtract bottom row from the middle row, but look what happens when I do that. Subtract bottom row from middle row, and I get that. Okay, how do we interpret that? What's that telling me? Say it again. Infinite solutions. Yep, absolutely. So this is telling me infinite solutions, right? Okay, but that by itself is not enough. If we want to be really specific and we want to know what the solution is, there are different options for that, right? If we think back to last week, there are different ways we could have infinite solutions when we intersect 3 planes. What's one way we could have infinite solutions? Say it again. 2 planes are the same, but one is not. Okay, that's fine. What kind of an intersection is that going to give us? If 2 planes are the same, but a third plane is different, we're going to get a line, aren't we? Right? Where all 3 of those intersect, we're going to get a line through 3-dimensional space. What's another way? They're all the same plane. Now that's different. That's a bigger type of infinite solution because if they're all 3 the same plane, then the intersection is not just a line, it's an entire plane, right? And then we could also have maybe 3 of them that intersect that are different planes, but they still all intersect on a line. Well, we need to know which one of those things is going on here. What did this tell us, this step right here? Yeah, okay, that planes 2 and 3 end up being the same, don't they? Okay, so 2 of them are the same, but 2 of them are different also, right? So this is one where we didn't just get everything canceling and get zeros everywhere in this whole matrix. We got some zeros in the bottom row, which tell us we have infinite solutions, but we got to go a little bit further to figure out what that means, okay? So now what could I do? My goal now would be to be able to find a way to relate y and z and x and z. So what could I do here? The top equation tells me something interesting. What about this one? I just would like to make that a 1, right? Whoops. So I could just do something like, what if I did 6 times row 1? Okay, actually, that's good. If we do 6 times row 1 minus row 2, what's that going to accomplish? That's going to give me a 0 there, isn't it? Anybody see that? Okay. So I get that. And now the last step would be I could just multiply each of these rows by 1/6. And look what we get. Okay, this is kind of a high level thing in a way, but this gives us our constraints. The bottom row tells us we have infinite solutions. Can you guys interpret this row for me? What's that telling me?
1y plus -7/6 equals 4.
-7/6z equals 4, right? So if I solve that for y, that's telling me that y equals 7/6 z plus 4. Okay. How about this top row? What's this one telling me? Yeah, x equals 5/6 z plus 1. So we have infinite solutions, but what this is telling us is that if z is the free variable, if z could take any value possible, whatever value z has is going to constrain the values of x and y so they all fit on a line. Okay? So this is one where here's how we'd have to input this. So you guys tell me which would be A, B, or C would be the correct option for what we got. Be B, wouldn't it? Right? It's going to be B. There are infinitely many solutions. And what's the solution set where Z is any real number? Well, that's what we just said. Z is going to be, or X is going to be 5, 6Z plus 1, and Y is going to be 7, 6Z plus 4. Okay? So it's a very specific type of infinity here, infinite solutions. But again, this is just going to be some line that's going to form a trajectory through three-dimensional space. Okay? Give me thumbs on that. Does that make sense? Okay. Okay, how about one like this? Let's just zip through this one a little faster, right? So does it make sense here that we could do, like right away, look at this. Those are all 8. So I could simplify that row by just dividing by 8. Make those all 1s. That's pretty handy. Then I could make this a 0 by multiplying the top row by 5 and subtracting the second row. It's going to give me a 0 there. I could make this a 0. Now, I could make this a 0 by multiplying the top row by 6 and subtracting the bottom row. And then I just need to, what happens? Okay, now look at those bottom 2 rows. What do you notice there? These 2 numbers are the same and this one is different. So when I subtract row 3 from row 2, those guys are going to cancel. Those guys are going to cancel. Those guys are going to cancel. Those guys are not. Right? So I'm going to get 0, 0, 0, 6. What does that tell us? We can be done. No solution. Yeah, anytime the bottom row gives you a false statement like that, where 0 equals 6, that means there's no solution. So those 3 planes never have a common intersection. Okay? Make sense? And if we had to answer that one, obviously that one's just going to be option C. Okay? All right? I'm going to turn you loose on this and just let you work away on this stuff. So both assignments are up. I'll give you a work day tomorrow on this to get questions answered and continue working.